Welcome to this video. My name is Mark Scythian. The date today is September 6, 2024. So this video presentation is titled Crude Oil versus Carbon Nanotubes. So if we focus on crude oil as a structural material source other than fuels, then we derive over 10 million more materials from crude oil alone, because the fundamental structural matrices of crude oil are repeating chains of carbon and hydrogen, also known as a polymer. So polymerization is when these CH chains can be broken down and rearranged into literally any other type of polymer-based materials. That includes all synthetic plastics, pharmaceutical drugs, road asphalt, paint, nylon, polyester, cosmetics, synthetic rubber, explosives, lubricants, etc. And we can go on and on. So anything that has a repeating chain of carbon and hydrogens is a polymer. And yes, you could make plastics and all these products from biopolymers, as in the oils of plants and animals. However, these products would be cost prohibitive. So if we went to a totally organic type of materials, they not only would fall apart sooner, but they would be cost prohibitive. They would cost many times more for a organic material that falls apart, and also cost more money. So people might take for granted, or convenience, many of the products they buy are just crude oil that's been rearranged into these common subsets in markets for materials. But if crude oil has a competitor with respect to materials, that would be the carbon nanotube. So these were developed in Japan about the 1990s, and the premise was taken from the invention of Buckminster Fuller in the 1950s, a geodesic synthetic molecule, a carbon-60 molecule. So these are just carbon atoms that are rearranged geodesically into finite mathematics, discrete finite mathematics to be exact. And so they find a parity in their electron structure and orbitals, thus reinforcing maximum strength. So this buckyball is not only a structure, but it can be programmed through both the physical and the biological electrical sequences. So what this means is that a buckyball could enhance a given organic or non-organic structure or organism or material. So that includes the physical and the biological materials. Now, if we rearrange the geometry of a C60 buckyball into a tube, and so we're talking about 1/billionth of a meter, so a nanometer. So one of these carbon nanotube segments could fit on a few propane gas molecules. So if you continue the sequences through electron assembly, you could get the same strength of a 2-inch diameter elevator stainless steel cable scaled down to less than 1/4 inch with infinite lengths where practical. So this experiment was carried out also in Japan to make a space elevator and to shoot a set of rockets and space stations into suborbit outside of the Earth's atmosphere, and then connect a space elevator through carbon nanotubes to test the structural ability and strength to weight ratios of these carbon nanotube strand cables. But what's interesting is that these carbon nanotubes, when arranged in such an electronic or electron geometry, have the ability to also receive software programming into the solid state. So now a carbon nanotube could become a structural material, an electrical material, a mechanical material, or a chemical material. So the whole premise of chemistry is changing the frequency and electron sequences via the quantum numbers and the quantum spin probabilities. So the entire material world is an electrical field. It's just that the practicality of going from electrical energy to physicality is on the entanglement of those frequencies. Hence, we have geometrical molecular dynamics. So this is just the molecular dynamics per se, and if we scale this out into different shapes, we can also have nano sheets of carbon-6 matrices. So of course these are carbon-6 hexagon matrices, then interlocked electronically into the substrate. So why not carbon nano sheets? Yes, we have 2 and 1 layer and 4 layer graphene polymerized and non-polymerized composites. So then you would have a little bit of the polymers from crude oils interlocking between purely graphene and carbon-6 chains. So in the real world, this is a benzene matrix. And so again, it doesn't have to necessarily be in a liquid solvent form. C6 is a benzene chain, electronically and frequency based. But what is the physical correlation on that material science to a polymeric C6? So there is a really good example of how you could cross over a more practical material at pennies on the dollar, much stronger and not non-toxic. So this is an importance to keep mindful of the nanotubes or the carbon matrices competitor to the source crude oil for material science. Now, if we were to look at the other half of crude oil for fuels or hydrocarbons, the competitors are of course, nuclear battery and also the geo-electromagnetic fields. So we have enormous concentration of electrical energy in the Earth's crust, as well as the Earth's magnetosphere. So if these contingents have a type of resonance finding their parity, then it is safe to say that high levels of electrical energy can be drawn out geomagnetically. So this is what Nikola Tesla was kind of working with, and how much of it was then picked up by the Department of Energy for government projects is quote-unquote unknown, but it's more than likely farther ahead than what is admitted. And so all of these different competitors are the missing links and correlations, which then lead to the discovery of what was hidden. So if the consumer market, or I will say the civilian market, can figure out all by themselves what has been hidden, then that is fair game. So keep mindful that we have the geomagnetic-electrical field as well as the nuclear battery as the competitor with crude oil with respect to energy, and then we have the carbon nanotubes and buckyballs and the carbon nanosheets in competition with crude oil as a material source. Thank you for watching this video and have a great day.